All right. If we're on here, good afternoon, everyone, and welcome. My name is Luke Hoban. I'm a program manager in the JavaScript group here at Microsoft. And today I'm here to give you your afternoon dose of JavaScript at the Build Conference. So the talk is specifically on modern JavaScript. And more specifically, is going to look at modern JavaScript on all of the Microsoft platforms. And so the JavaScript that you're able to use across the various platforms we have. When I talk about modern JavaScript, though, I should start by sort of giving a history of where JavaScript has come from and some of the things that sort of the modern era of JavaScript development really differentiates itself from some of the history that JavaScript has had. So JavaScript started out in 1996, was when it was first created and first made available in browsers. And I searched around on the web for examples of code that was written in 1996, which it turns out is actually kind of hard, finding content from 96. It's kind of been drowned out by all the content created since. But I found this one on a site called Free JavaScript, which I loved because, you know, who wouldn't want an alert box on their web page, right? How awesome is that in terms of sort of cutting-edge, rich internet applications? But this is, this kind of thing was actually significant when JavaScript was first made available. The kind of interactivity you can get when you have a scripting language is, of course, significantly more than just with pure declarative markup. But of course, it wasn't long before people, as soon as you give them a tool that has the kind of power that something like a full scripting language has, they're going to find ways to leverage that to build much richer applications. And so things like at Microsoft, the Outlook Web Access team built an application which you're probably not going to mistake this for the desktop version of Outlook. But at the same time, it's got a lot of the functionality. And this was in 1997. And so it's a very kind of rich applications we're able to build with JavaScript. Fast forward several years. And you have things like this quote that I found somewhere that from some folks at Google saying that Gmail, and this was in 2010, so I'm sure these numbers are much bigger now. But the Gmail is comprised of a little under 500,000 lines of code, or almost 1 million lines of code if comments are included. And of course, we have lots of projects inside Microsoft as well that are at this scale or larger, where we're building some very, very large applications authored primarily in JavaScript, running in the web client. And so this kind of scale, this is huge. I mean, you're thinking about managing 1 million lines of code, the size of a development team that's involved in that. This is really a very different thing than what you saw up there in the top left. The other big trend that's happened, which has really changed JavaScript in a significant way, has been performance. There was a talk yesterday on JavaScript performance specifically, so I'm not actually going to talk much about the details of what's changed with performance. But in terms of the way you should think about JavaScript performance, I will touch on that a little bit today. And I think this graph is pretty striking. So this is about 10 years between 2001 and 2011. And anytime you see a graph that looks like this sort of hockey stick thing, right, that's a good thing, right? That means things are going up and going up fast. But when I then tell you that this is on a log scale, that should really blow your mind, right? So this means that in 10 years, we had 100x improvement in performance. And this is just Internet Explorer, and this is just on SunSpider, so it's just one data point. But 100x increase in performance. That completely changes what you can think of trying to do with that runtime environment. And indeed it has. We've certainly seen that, that sort of when people can target and trust that they'll have one of these modern engines that has this kind of performance, they can start building really, really rich applications. And one of the notable things here is this is in 2011 that we got this kind of performance. So that's just starting to be something which the broad full web can take advantage of. But when you're doing things like targeting some of the specific device ecosystems that we have, like when you're targeting Windows 8 applications, you know that you have this high-performance JavaScript engine. And so when you're building for that environment, you can assume that as part of your design. And that means you can really take advantage of that runtime much more significantly. So that was just some little some kind of history. What I'm going to talk about today is sort of modern JavaScript from 3 perspectives. The first is the language. So the language has actually changed in the last few years, something that not a lot of folks actually know about, and so I'll touch on a few of those things. The second one is the libraries and the core runtime that's available with JavaScript. And 2 things in particular that are really significant scenarios that have been enabled. One is working with binary data, and the other is using multiple cores and getting true concurrency inside the browser. And then last, I want to talk about how all this feels across all the different platforms. So you can use JavaScript in on the web, in Windows 8, in Windows Phone 8, and in Windows Azure. So all the platforms that we're kind of talking about here at the conference this week. And so I'll tell you a little bit about how JavaScript looks in each of those environments. So for the language. So JavaScript is a standards language, as folks are aware of. And so the standard that describes JavaScript is called ECMAScript. And ECMAScript was, I mentioned that JavaScript was created in 96. It was actually first standardized very soon after its creation in 97. And you'll see there was very rapid iteration on the standard, and there was a lot of features added to JavaScript over those first 5 years or so. But then there was a period where there was much less activity with the JavaScript language. And one of the things this has led to is that most developers think of JavaScript as being one fixed thing, because for the entire lifetime of their work with JavaScript, it really has been. For 10 years there was actually no changes to the language that was implemented in browsers. But that's actually starting to change. So in 2009, ECMAScript 5 was ratified as a standard. And in the years since then, we've been implementing in IE and in all the other major browsers. We've been implementing support for the new capabilities of ECMAScript 5. And so almost all those features in ECMAScript 5 were actually available in IE 9. But the one last feature from ECMAScript 5, which I'll talk about a bit later, is in IE 10. And so now we have full, complete implementations of ECMAScript 5 in IE. And similarly, all the other browsers now have full implementations as of the last several months. And so I think this is a significant thing, the fact that the language has actually changed. And it changed in some fairly incremental ways. But it means that there's now actual things in the language that you can leverage that weren't there over the last 10 years or so. The one last thing to note on this is that the standards group is now more actively engaged in working on the language. And so that means that the standards group is actually working towards a next version of ECMAScript as soon as the end of 2013, although that date may end up sliding out a bit longer. But that means that we should expect to see some continued momentum on the actual language and capabilities of JavaScript moving. And so this trend is something that's just beginning again. So I'll touch on a couple of the things in ECMAScript 5 that are kind of worth being aware of as you're working inside these platforms where you can use ECMAScript 5. So the first thing here, sort of the JavaScript 101 is, every object in JavaScript is just a property bag. It's a map from property names to values. And so you have things like this bank account with an object literal. One of the things that changed, one of the problems with this kind of thing is that I can't run any code when that property gets looked up. So when someone accesses the balance property on my object, they just get back the value. I can't say, actually, I want to run some code and log that someone accessed this property or anything like that. And so what you could do is make this thing into a function and then run some code inside that function. But then every caller of this API needs to change to call it as a function instead of accessing as a property. And so ECMAScript 5 added the ability to have getter-setter accessor properties. And so this accessor property down here creates an object which, from the outside, looks just the same as the first object. It's just an object with a single property called balance. And when I get it, it's going to return 1257. But when I set it, it's actually not going to do anything. It's just going to ignore the attempt to set it and not actually change its value. And so what this allows me to do is actually intercept calls. So I can actually run some code when when someone gets the value, and run some code when someone sets the value. And folks who've used languages like C# will obviously recognize this kind of thing as the notion of properties in C#. But this is something that's actually available now in the core of the JavaScript object model. So any property you work with can be an accessor property. And so that starts to change this notion of just a JavaScript object as a property bag where names map to values. Names actually map to either a value or a getter-setter pair. But it turns out they actually map to a little bit more information. And although all this information here was actually part of the JavaScript runtime in the past, before ECMAScript 5, there was no way for user code to learn about and change any of this. So you couldn't actually ask whether a property was writable, for instance. But now, properties can have this additional metadata associated with them. So a property can be writable or not, which indicates whether we can actually come and change the value if we assign to it. It can be enumerable or not, which changes what happens when we do a for in. So we might want some properties not to show up when we iterate over the keys of an object. And it can be configurable or not, which means can I come in later and change these property descriptors here. Can I change it from being enumerable to not being enumerable later on? And so this metadata here is actually associated with every single property on every single object in the system. Of course, the runtime is optimized the way that that's all stored, but you can actually go in and reconfigure all of this information on objects. The other kind of descriptors we talked about, there's accessor properties. So the other kind of descriptor is the ability to have a get-set pair. And of course, when you have a get-set pair, whether or not you have a setter is the same as whether or not you're writable. So that's a quick look at a couple of features. One thing I wanted to do was just show what some of this looks like inside IE. So here I am on the Bing homepage. I'm just going to open up the developer tools. So I'll make this full screen here. And let me just refresh that. So we're, we got to plug in a network connection here. Sorry about that. Give it 1 second. All right, I'm just going to close this and open up one more time. Okay, there we go. So we have Bing here. I'm going to open up the developer tools, come into the console. And I'm just going to write some code inside the IE developer tools here. So I'm going to start by just writing a simple object. And I'll write hello :42. And I do apologize. This is a little small. Probably some in the back are having a little bit of trouble seeing it. Unfortunately, I can't up the size inside the IE developer tools. One of the features I would really like that team to add. But let me just go and say get own property descriptor. And so this is a function which, as its name quite explicitly says, gets the property descriptor that we showed on the last slide associated with any property in the system. So I can come up to this O object and look up its hello property. And you see that I get back a descriptor, just like on the slide. So this one, its value is 42, as we expect. And you see that by default, properties on objects which you create in JavaScript are writable, enumerable, and configurable. So very open-ended, very permissive. But we can try to do this on other objects in the system. So we can come to something like date.now, a useful function in the JavaScript core libraries. In this one, as we expect, its value is a function, because date.now is a function I can call. But you'll notice that it's not the same as an object that I created by hand. Instead, its enumerable property is set to false. And so in the past, it was actually the case that built-in library functions and things injected by the DOM actually had things like this behavior where they were non-enumerable. But there was no way to discover that and find out that information. Now you can. More interestingly, though, we can do things like look up HTML element.prototype, and we can look up its inner HTML property. So the inner HTML property, which you probably use a little bit, is a property, obviously, that's shared across all HTML elements. And so this property, it turns out, is actually a getter-setter pair under the hood. And so the IE9, starting with IE9, the DOM in the Microsoft Web Platform actually leverages getter-setters heavily. So every property that you're working with inside the DOM is actually under the hood a getter-setter pair that's being called on every read and write. This is actually now being specified in the standards body with the WebIDL standard. The one interesting thing, of course, is we talked about how you can use getter-setters to sort of intercept calls and do interesting things when these properties are set. So let's just kind of do something like that. Let's write some code which intercepts every attempt to set the inner HTML property. So what I'm going to do is I'm going to get that property descriptor and call it old descriptor, and then I'm going to write a new descriptor. And I'm just going to replace the one piece of this descriptor that I want to replace, which is the setter. And so I'll have when someone tries to set the inner HTML text, I'll call this function. And what I want this function to do is just log out what got set. So I'll say console.log, and I'll say inner HTML set to text. Now I've actually logged that out, but I need to actually still do whatever the setter for inner HTML would have done. And so in this case, I'm going to grab my old descriptor. I'm going to get this set property on there, and I'm just going to call it, passing this and passing text. So now I have a new descriptor, and now I can use the opposite method, which is object.define property, to define HTML elements prototype, inner HTML property, to be this new descriptor. So basically what I'm doing is I'm grabbing the old descriptor, making up a new one, and then jamming my new one back in. So I'm replacing the shared version of this inner HTML property. So I'll run this, and now I'll come back over to Bing, and what I'll do is actually move this to half screen so we can see. So on the Bing site, you may have noticed that there's these nice little things which flip back through the previous images. And each of the images has these nice little quotes, but to get to them, you kind of have to mouse over these things, and it takes a while. There's a fade operation. So wouldn't it be easier if you could just have it print them all out, right? And so with this little injection trick, I can capture every time when they're setting the inner HTML, and I can print that out to the console. And so now every time I navigate between these pages, we actually see it prints out all of those pieces of HTML. And so you can see that these kind of tools, these property descriptors, are a nice way of actually looking sort of inside the engine, what's going on. You can use these to intercept calls, to do some of these kind of introspective operations. So just a fun little look at how those property descriptors work inside the DOM. OK, so another new feature in ECMAScript 5 is some of the array APIs. So I imagine that pretty much everyone in this room has written effectively this same code right here. Very, very standard pattern. There's two interesting things about this, though. The first is, at least for me, whenever I start writing, I realize I need to write this piece of code here. I sort of mentally have this, oh no, not again kind of thing, right? Like my fingers are just programmed to like write out this magic string of characters here, this var I equals 0, I less than, in every C-style language I've ever used, right? You just write out this stuff. But it's just boilerplate, right? This is this exact piece of code here is something that you write over and over and over again. But if that was the only problem, this might not be so bad. The bigger problem is this reference to I down here. So how many people have been hit by the bug that I'm showing here? Or how many people recognize what bug I'm showing here? So the bug that I'm showing here is that the I I'm referring to here is the loop iteration variable. And so that's actually going to change. And so I'm calling set timeout and sort of telling it to wait before it prints this out to the screen. But all of these set timeouts are actually, when they resolve, are going to refer to the same I, which is going to be the last I. So this code is not going to do what I want and print out ABC. This is going to print out CCC. And so this kind of thing is a really subtle bug because it's a timing problem, depending on whether this set timeout resolves fast enough before, whether it resolves immediately or on a new turn of the loop. I might not notice this. And so this kind of thing is really, really kind of dangerous and really easy to accidentally do in JavaScript. So you can fix this. You can put this little function closure around here and call and pass I in, and this. Every time folks look at this, they're like, I have no idea why this works, but it seems like it solves the problem. It feels like just a magic kind of hack that fixes the problem, right? It doesn't feel like this is how you should have to write this code. And so one of the just really convenient things that ECMAScript 5 added is for each. So on an array, you can say array.forEach, pass it a function which accepts the item and optionally accepts also the index. And then you just write your function. And you're now isolated from any of those issues with the reference to I. And you don't have to write that boilerplate. So this kind of thing is just handy. Once you have this, you find yourself using it just all over the place as a tool for doing iteration. And of course, it's not just for each. There's a whole bunch of new array APIs. So things like maps and filters, things like reduce and reduce write, and even some handy ones like indexOb that weren't there in the past. So these are just something that once you have them in the libraries, you're going to find yourself using them quite a lot. The last thing I want to talk about for the JavaScript language is strict mode. So strict mode is the one feature that was not in IE9, but is now in IE10. And strict mode is a sort of opt-in that you can add in your code that tells the runtime to sort of enforce a stricter interpretation of the JavaScript semantics. And the way you opt in is this little string up here. So you put this magic string, use strict, as the first statement inside some lexical scope. So in this case, inside the function body. And the reason, people always wonder, so why is it this weird string like this? Why didn't you just add some syntax that said use strict, and then it could be colorized and actually look like I meant to put it there instead of like I just left a string in? And the reason is actually backwards compatibility. So if you make this a string, it means that any old browser out there, if it runs this code, can still work correctly. It just interprets this as being a string and ignores it and doesn't do anything. But a new browser can treat this use strict as an indication that it should move into this new mode. And of course, this isn't 100% backwards compatible. If someone happens to have existing code which started with the empty string literal use strict, it would technically break that code, but the chances of that are so unbelievably low that it was considered OK. So what does use strict buy you? So it basically does what it says. It's a bit stricter. So it does things like, if you try to assign to a variable which has never been declared, so in this example, I didn't write var x anywhere. If I try to just assign to a variable, I get an error. This is, of course, really easy mistake to make. You just mistype the name of something, and you might have this problem. Or you forget to declare some variable in an outer scope. And this is almost always an error in your code. This is almost always something which is going to blow up at runtime. And so, it's going to do something you didn't expect at runtime. This now makes sure that fails early so that you can catch those bugs. And we've seen some pretty high-profile cases of this kind of issue causing sites real problems. The second one, another thing that strict mode generally does is actually constrains the system a little bit for kind of security purposes. So one of the things that is somewhat sort of enables code to be very invasive in a sense is the ability to use arguments.caller and callee, which let you walk up the call stack effectively and look at all the function objects which called you at runtime. And of course, this means that it's very hard for code to ever be sandboxed. So if I want to call into some code that I don't trust, I can't really do that because he can just come back and look at all of my call frames and see what functions called him. And so he can learn a lot more about the system than he should be able to. So strict mode actually constrains a few of these things, makes these an error. And then other things like, for historical reasons, when you set a non-writable property, if you try to change the value of a non-writable property, JavaScript just ignores it. So it doesn't throw an error, but it doesn't change the value of the property. And so this kind of thing can be very difficult to figure out later on. You're stepping across this line of code, and it just didn't do anything. And you're why is that happening? Here, when you have strict mode on, that's just going to throw. You're going to find out about that early on. That was almost certainly an error in your code. So a bunch of things like that that strict mode enables. So let me just come over here and quickly show you try strict. So how many folks have checked out any of the IE test drive demos in the past? So a few folks, but definitely not a lot. These are actually really great. The IE test drive site, ie.microsoft.com/test drive, has a ton of these like simple focused demos that show off some feature that's been added into the Microsoft web platform. They tend to be really interesting ways to actually look at a particular feature and learn about what it can do. So when we implemented strict mode a while back, we put up this try strict thing, which gives you an environment where you can just sort of try out some code. So here we go. We have use strict, and we saw that if you try to assign to an undeclared variable, that's going to produce an error. And of course, if I remove the use strict, we'll see that when I run this, it does not produce the error. And so this is the kind of thing that we can catch. And so this gives you a simple, you can go through here and look at some of the different things that are enabled with this. One that's particularly fun that wasn't on the slide. If I do something like this, in JavaScript, when I do an eval, if the eval declares new variables like var x equals 5, that variable actually gets injected into this point in the scope. And so this return x here will actually return 5 because of what the eval changed the meaning of x locally to that function. And this kind of thing is, eval is plenty dangerous by itself, but this aspect of eval is especially dangerous because it means that if you eval some text and it happens to have a variable declaration in it, it can change the meaning of an arbitrary number of the bindings in your code. And that means that optimizing compilers, basically, the engines, basically have to bail on every piece of optimization they would be trying to do as soon as they see an eval like this, because they can't trust that x means the thing that they thought it might refer to. And it also means that static analysis tools, which are increasingly important for building scalable apps, can't really correctly analyze this code because they would think x refers to the outer variable. They can't see that this eval is going to happen at runtime. So that's strict mode. The other thing I wanted to show while I'm here, I've shown several of the new features of ECMAScript 5. One of the other things that's happened during the period where ECMAScript 5 was being developed was that we worked with the standards body on establishing a test suite owned and managed by the standards organization, which we could all contribute tests into, which would validate that we had correctly conforming implementations of the ECMAScript standard. And this has actually been really great, has shown really great results. I'll start this running. It's actually got 11,000, more than 11,000 tests here, so it's going to take a while. I'm probably not going to let this finish. But this runs an enormous battery of tests developed by many of the browser vendors and contributed into this test suite that can validate a ECMAScript implementation. And IE is currently doing quite well on this. There's only, I think, one test that we fail right now, and we generally try to make sure that we keep ourselves as close to zero as we possibly can. But even more importantly than that, what this test suite has done is meant that all of the browsers are now actually doing very well on this test suite. So all the browsers have done concerted efforts to bring up their standards compliance, driven by what this test suite has done. And that means that generally, when you're using JavaScript today versus when you were using JavaScript 5 years ago, you can actually trust that if you're using a modern browser, all of them are going to implement the same standard in the same way with the same behavior. And I think that's something that this test suite has really done a good job of driving, is that you can have a much higher level of trust in that cross-browser compatibility for JavaScript than you did several years ago. So, okay, so I'll stop that for now, and we'll swap back into some slides here. Okay, so the second section here is about some libraries and runtime capabilities. In specific, I want to talk about binary data and leveraging multiple cores. So binary data is kind of particularly interesting because one of the things that JavaScript has historically not really been able to do was do sort of byte-level manipulation. So do anything that required me reading the bytes of a binary file or doing some byte-level operations in memory on some data at really high performance. These were things that were not available to JavaScript, and they limited in a significant way the kind of applications you could imagine building with JavaScript in the browser. And so with typed arrays, we've actually gone and provided the sort of fundamental tool that you need to enable you to do binary data manipulation. And so typed arrays is a new API. There's two key pieces to a typed array. The first is an array buffer. So I can just allocate in a new array buffer. So here I'm saying new array buffer 8. And this just gives me back a block of 8 bytes of memory. It's an opaque block of memory. I can't really do anything with it using the array buffer interface. But I now have a handle to 8 bytes of memory. What I can do with it is I can layer views on top of it. So I can create something like a uint8 array passing at the buffer. And what that does is gives me a view of that memory as an array of uint8s. And so now when I index into that and assign the values in, you'll see like in this picture down here, we end up with this 0x05 in each of the 8 bytes of this block of memory. But we can layer multiple views over that as well. So we can layer a uint32 array over that view. And that gives me a view of the same block of memory, but using uint32s. And so this can be a tool, for instance, for viewing just raw memory through various different lenses and converting between different representations. I can even do things like look at the bytes of the representation of a floating point number, for instance. That's something that was not really possible in JavaScript before. And so this is, you can see here, you're doing really sort of low-level byte manipulation. This is something that wasn't possible really before typed arrays. But probably more importantly than just the raw computational aspect is the connection into all of the APIs that are available in the browser. And so typed arrays are now integrated in our web platform into many of the ways of interacting with I/O. So for XML HTTP requests, you can send or receive binary data and ask for it to be sent or received as an array buffer. And so you can fill one of those up in memory and then return it as part of an XML HTTP request. blobs and files, which are also some new concepts from the W3C in the web APIs, give you the ability, for instance, blobs give you the ability to create a URI which you can use somewhere within your application that refers to some in-memory data. So for instance, I could create a blob using some arbitrary data in memory and then use that as the source for an image tag, for instance, to give myself the ability for an image tag to reference some in-memory information. And we can create a blob using an array buffer, like the bytes here. And lastly, WebSockets. If we're doing, if we're using WebSockets as our communication mechanism with our server, we can send array buffers and these bytes directly across to the WebSocket. So the fact that this is integrated into all these forms of I/O in the browser means you have rich access to work with binary data in a lot of different forms. So let me show you an example of what that looks like. Come over here into another one of our test drives. So this test drive is a binary file inspector. And so this binary file inspector, I'll just come up here and grab, for instance, a JPEG image. So this is a JPEG image coming from the server, and so I'm downloading this using XHR from the server. And I'm grabbing it as an array buffer. And what that means is I can then go and look at the bytes. And so here we see a sort of a hex editor view of this file that I've created from within script running on my page. So I didn't have to do this on the server. I'm actually able to tear apart this file inside the client and figure out what bytes are in it and show you a representation. You can see things like some of the JPEG headers in here and that sort of thing. If I come over to a video, you see that this is a F-type MP4, so this is all part of the file format for MP4 files. But then I can also take that same content and render it inside of the window here. Now those are sort of fun. The ability to actually look inside the bytes of a file is kind of fun. But where it starts actually getting interesting and useful is things like this PCX example. So this file here is a PCX file. So how many people have ever used a PCX file in their life? Is anyone? OK. So not many, because PCX files have never been supported in any browser. They're sort of an old file format. Most image editors don't even support them these days. But it's a file format that was used in some graphics software in the 90s, I believe. But of course, no browser knows how to render these files. But what I can do is, because I have access to typed arrays, I can download that file content from the PCX file. I can rip apart the bytes and actually implement the specification of the PCX file format. And then I can use Canvas to render that into my browser. And the end result is that I can actually get the ability to render custom image types inside the browser. And you could imagine, for instance, this allows me to, on an older browser, implement some file format which is only supported on newer browsers in just a less performant way. I have to do it manually through some JavaScript code. But this kind of thing is really kind of powerful, the idea that new file formats can actually be interpreted and rendered inside the client from JavaScript. So this idea, of course, here it's a PCX file, as you saw from the hands. Not many people have used those, so that's maybe not as exciting. But some folks have done some really interesting things with this, like this PDF.js tool that's been built by some folks at Mozilla, for instance, is effectively doing the same thing as what I just talked about. It's going and taking a file format, ripping it apart in bytes, and then interpreting all of those and rendering them into the screen. And so this is actually rendering a PDF file. And so this is actually grabbing the PDF as bytes and rendering it all inside the client, but without any plugins. So this is purely done inside an HTML5 compatible browser. And so this is kind of a powerful idea that you can actually take something as rich as PDF, very, very rich, expressive file format, and render that purely in the client. And as you can see, the performance is actually quite good for this kind of thing. So this is the kind of thing that's enabled here. OK, so let's go back. So the next one of these features that I want to talk about is web workers. And web workers are really about, so let me start with some of the history here. So probably everyone here is familiar with the idea that JavaScript is just a single-threaded runtime environment. So when you're running inside a web page, you have just a single thread of execution. Any code you write that takes a long time is going to block the UI thread until your work is done. And because of that, JavaScript has grown up being very good at having asynchrony on the UI thread. So everything in the system is sort of event-based and asynchronous in a way that makes sure that no code that you write is likely to have to sort of block that UI thread for very long. But if you do want to do something computationally intensive in JavaScript, you have to be very careful about how you do it, because you need to make sure you break it up into chunks that are small enough that no single one of them takes too long that it's going to feel like the browser is becoming unresponsive. So what web workers do is they give us additional threads of execution that we can use from within a web page. So they allow true concurrency inside the web browser. And web workers work like this. So we can, inside our index.html, we can create a script tag and then new up a worker. And when we new up a worker, we pass it a URI that is going to be the JavaScript file that's going to execute within that additional thread of control. So within that worker thread, we're going to run the code inside this adder.js. And then we do two things. We set up a handler to listen for messages sent from the worker. So when the worker sends us a message, we're going to run this code here on the UI thread. And then we can send the worker messages. So here we're going to send the worker a message saying we'd like you to add the numbers 47 and 32. And so then on the adder side, we sort of have the same thing, but in reverse. So we can hook up onMessage to be a function. So whenever the worker gets sent a message, it will run this code on that message. And then when it's done doing its work, it can post message back and send a response back to the client. And so this is called sort of message passing. One of the key characteristics of this is that there's no shared memory. So all of the sort of mutexes and locks and monitors and all this kind of thing you may have seen if you've been doing sort of concurrent programming in Java or C# or some of those kind of environments. None of that comes into play here. None of the sort of race conditions, any of that kind of thing can ever happen in this environment, because every time you want to communicate between the two parts of the two threads of execution, you have to manually pass some data, and that data is copied over into the other thread of execution. This isolation means that none of the code has to worry about other code preempting it or running or executing something random in the middle of me running, and I have to put a lock around it. So this shouldn't make you any more worried about the meaning of your code. You can still reason about your code in the same simple way as you always have been able to in JavaScript, but you can get the benefit of having multiple threads of execution. Okay, so let's look at an example of that one as well. Oops. So I'm going to come over here and open up this file here. And this is a simple little ray tracer application that I wrote. And so I'm just going to click here to start. By the way, for those of you who have ever seen me do presentations in the past, you've probably seen a ray tracer. This is my go-to thing. I think I've written this in about 17 different languages now. But this is a simple example of running a ray tracer algorithm. And you saw that was running just sort of top to bottom. It took about 13 seconds there. And actually, let me run that again. And one of the things I'll show is that although it's taking a little while, you see how the browser is fully responsive. I can scroll around. I can resize the window. So I haven't hung the browser process, even though I'm doing very, very compute-intensive work here. And I'll show that even more viscerally here. So I'm I'm using up a whole core on my 4-core laptop here. And I'm doing very compute-intensive work, but I haven't hung the browser. And this is something that without web workers would be very hard to do. I'd have to be chopping this compute up into pieces, making sure I posted it back. Unless I organized that just right, I'd probably be losing performance opportunities as well. And so it'd be very hard to organize that without web workers. With web workers, though, this kind of thing is quite easy. So let me come over here into Visual Studio, where I have open the code that implements this. And so this is my index.html of this application. And you notice that I say that num_workers equals 1. So I'm going to use one worker for this code. And what I do is basically just exactly what I showed on the slides. So I new up some workers, pointing them at a file which knows how to do all the computation. When I'm ready to go and execute this, for every line of the image I want to show, I basically pick a random worker and then post a message to it asking it to render line Y of an image of that width and that height. And so I can sort of post messages randomly to the workers. And then when they're done, each of those workers will call the message handler, which knows how to grab the data back from the worker and then render it into our client. So one of the fun things I can do, of course, is I can up the number of workers here. So instead of having one worker, I'll just have 4. And if I refresh and click Start here, you'll see that now we can sort of viscerally see that this is happening. I was randomly picking workers, so some of them are getting ahead of the others because they're getting backed up more. And And we see that by doing that, I'm actually able to execute this much faster. So it's taking around half as long as it did before. And if I come over here, you'll see that I'm actually also using up my computer's resources much better. So here, instead of just using up one core of my machine, which was all I could possibly do from a single tab before Web Workers, I can now actually use up more of that compute resources that are available inside the client. So that's nice. So with four workers, I can get a bit of a speed up. So well, that sounds good. So why don't I just like make this 12, right? And if this works, I can just keep upping it, right? And I'll run this again. And you do see that it looks a little bit different. You do see these lines get spread out more. You can see that the handing these out to the arbitrary workers is creating a little bit more dispersion there. But you see that the rendering time ends up being about the same, right? It always ends up being about 8,000. Of course, if you think about it, that almost has to be true, right? There's only so much resources. With 4 workers, I had 1 per core, so I'm using them all up. Here, though, we had 12. And so the nice thing, though, is that we can create as many workers as we want. And the browser is actually going to take care of scheduling those into our actual threads of execution on our box. And so we can create as many of these things as we want, and it will be smart about using them. But of course, if we create 12 of these, we're not going to be able to leverage, we're not going to get increased performance unless we have an 8 or 12 or 16 core machine on which we're running. And so that's a simple look at some web workers there. Okay, so for this last section, I wanted to talk a little bit about JavaScript as it applies to some of the Microsoft platforms and some of what we've been doing there. And of course, probably one of the most exciting platforms from this perspective is what we've done in Windows 8. In Windows 8, we've actually made it possible to build applications fully within JavaScript. So you can use all JavaScript assets and build a rich application. One of the things, of course, that's necessary to enable that is that JavaScript then has to be able to call into all of the Windows APIs it needs to access all these Windows 8 application capabilities. So things like interacting with those search charms and share charms and that kind of thing on the right-hand side, interacting with other shell behaviors, lots of different capabilities related to the Windows operating system that we want these applications to be able to access. And so one of the things we've done is obviously take those WinRT APIs and make them available within JavaScript. And so looking at what this looks like in terms of the APIs available to developers working on our web platform, in the IE9 timeframe, these are approximate takes of how many APIs there were in the system. And so these are all the web standards APIs that are available inside the browser. You see that our JavaScript engine has a few APIs, and our web platform has quite a lot, the DOM and XHR and all these sort of things. In IE10, we added a bunch of new ones. I mean, this is almost 30% growth, I think, there. That's a lot of new APIs that are made available. And so things like what I showed on previous slides, typed arrays, web workers, a bunch of other additional APIs that were added in IE10 in the web platform. And all of that is available, of course, on the web, but also inside these Windows 8 applications. What's amazing, though, is that when we're working inside a Windows 8 application, we have access to effectively all of Windows that's available within the modern Windows Store apps. And so here we see that the number of WinRT APIs is enormous. There's a ton of capabilities that are exposed there. And so when you're working as a Windows 8 developer, even though most of your time is going to be spent using the APIs on the left, there's a really new, rich set of APIs available to you to use. So let me just go and show you some of what this looks like. So I'm going to just open up a grid application here. You can create one of these from scratch. The first thing I actually want to show before I go into the WinRT component here. So how many folks have built a Windows 8 application using JavaScript? Great. Okay, so a fair few folks. So one of the things you've probably seen if you've worked with that is WinJS. So WinJS is one of our libraries. It's a pure JavaScript library that helps you to build Windows applications using JavaScript. And one of the things it does to help you is provide some simple libraries like winjs.class.define and winjs.namespace.define. And so what I can do is right-click and say go to definition inside here. And you see we come to the innards of WinJS itself, and you can see how this is implemented. So there's a couple of things I wanted to show. One is that WinJS itself is actually taking advantage of the fact that it's running inside a guaranteed ECMAScript 5 compatible environment. So So it's running inside Windows 8, which is always going to have ECMAScript 5, which means it can take advantage of these features, which I showed on some of the early slides. So it can take advantage of having a getter. So this not supported for processing should be just a basic property on the strings. But when that property is accessed, we're actually going to make a call and go and grab some resources. So they want to run some computation as part of accessing that property. So we can use getters there. We can do something like enumerable colon. So you'll see that there's quite a few places inside these libraries where they're actually using these property descriptors as well. So for things like defining new classes, defining new namespaces, they want to control the way in which those classes and namespace objects look. And so these low-level libraries like this tend to take advantage of some of these techniques of using property descriptors. And of course, things like .forEach. As I mentioned, as soon as you have this, you tend to want to use it. Inside these libraries, you'll see lots of uses of things like forEach and the other APIs. So heavy use inside the WinJS libraries of ECMAScript 5. What I really wanted to show here was WinRT. And so let me just kill all this text and just write some code here from scratch. So WinRT is available under the Windows object. So I can just come into any JavaScript file inside a Windows Store application here and type Windows dot, and I get all of the APIs available in Windows. This is things like, under storage, I can get file access, so all kinds of different access to files. I can get under devices. Under devices, I can get access to geolocation and printers and all kinds of things, all kinds of capabilities which aren't directly available within the broad browser environment. The one I want to show really quickly today is media.capture, camera capture UI. So this allows me to capture images using the webcam on my computer. So you see a couple of things. One is that obviously our Visual Studio tools have a good understanding of these WinRT APIs, so they can provide information to me. And this one's telling me that to use this, I need to add a capability. So let me just do that so I can have the demo actually work. And now what I'll do is just create one of these. So one of the nice things is that all of these WinRT APIs are projected into JavaScript in a way that feels just like any other JavaScript object. So this camera capture UI is just a JavaScript constructor function, which I can new up. And when I do, I get back a JavaScript object. This JavaScript object is one on which I can do things like call capture file async. And then I need to pass that a Windows Media Capture camera capture UI mode. And I'm going to ask for a photo. So I can write simple code like this. So let me just comment these guys out for a second. What I'm actually going to do is just run this, switch back into Visual Studio, and now I'm going to run this code live inside the JavaScript console. So let me grab this here. And the JavaScript console, by the way, this is something that was new in Visual Studio 2012. We actually took some of the tools that are available inside the browser and moved them into Visual Studio. So things like this JavaScript console. I can actually write code at runtime against the running instance of my program inside this JavaScript console environment. So let me create one of these dialogues. Immediately notice that, as I said, this thing is just a JavaScript object. So the view that I'm getting here is just the normal view that I would get inside the console for any JavaScript object that I was working with inside the DOM. And so it's got these operations we saw and some settings. Actually, I'll dive into these settings. You'll see, we can dive deeper and deeper in, and it's all just normal JavaScript objects that we're looking at. But these objects are actually giving me access to the core file system beneath me. Let me go and take this second line of code here and grab a photo. And what I'm actually going to do, since this is an async call, it's going to return a promise. And so promises are the way that we do asynchronous programming inside the Windows 8 APIs. And so I'm going to return that promise and say var p equals. And that means I've kicked off this capture file async. Oh, yes, that was it. So I've kicked off this capture file async. What I'm going to do is I'm going to say p.then. So when this completes, I'm going to say take the file that it returned, and I'm going to store it in the photo variable. OK, so I've written some code. If I look at photo now, we'll see that it's not yet established because I haven't completed that call. If I come back to my app, I think I didn't. It didn't work there. All right, let me just try it one more time. Create the dialog. store that. Come back here. Oh, it's not wanting to show me. Okay, I'm not sure why it's not working. I think it must be the projection of it. But if I did this, it would show me the actual camera capture capability. And if I clicked on it, I'd see the image that I captured. And then I could actually grab back in here the file object. I did change the manifest, yeah. Well, it should pop up a thing right here. I think, yeah, it's got some of the UI, but anyway, it's okay. The only thing I wanted to show related to that specifically was the thing I get back from this is actually a file object. And that file object is interesting because it's actually, the things that are available, the properties that are available on that file object are the ones that represent everything that Windows knows about that file. So all the metadata that's associated with the file, the ability to move it around, copy it, all that kind of thing. I have a lot of access to the information that Windows knows about that file. So this isn't some sort of dumbed-down API that sort of sandboxed the browser environment. This is really the full, everything that Windows, all the capabilities that Windows has for reasoning about that are available to me as a JavaScript developer when I'm working inside this environment. So that's quite nice. Okay. Skip that. We'll talk to some of that stuff. So the last thing that I wanted to do here was kind of do this look at how JavaScript, what JavaScript looks like across all the different Microsoft platforms. And so I'll swap back into this demo again. And I think one of the amazing things in a sense is that JavaScript actually can travel across every one of the web, Windows 8, Windows Phone 8, and Windows Azure. And so we can actually take code. In fact, we can take the same code and run it in all of those 4 environments. And so what I want to do here is actually just do that. So I'm going to take some code that I have. So we had this application here. I'm going to add some files. So we'll go into C:\demo. So earlier we looked at this ray tracer, and it was these 2 files, index.html and ray tracer worker. And what I'm going to do is just add as link. So I'm going to add exactly the same files that I had before in here. I'm going to change the default URL from being default.html to being index.html. And I'm going to rerun my application. And now we see that I took that same code I wrote for the web, and I'm just putting that inside a Windows application. And I can click this and run it. Oh, I'm in debug mode, so this is going to be a bit slow. Let me just close that and start it again. So if I come in here and run it not in debug mode, we'll see that we're still getting that great capability of running all 12 threads and things. We're using the web workers inside our Windows application. And maybe even more interestingly, I didn't show this before, but if I come into this ray tracer worker, you'll see that it's doing things like using for each, and it's got a getter property. So this is using all those ECMAScript 5 capabilities, but it's using the exact same code unmodified in the web and in a Windows 8 application. So that's kind of neat. Let me actually come in here and modify this back to 4. Okay, so we've got this piece of code here. So let's try that in one of our other platforms. So I come over here and create a Windows Phone application. And one of the templates that Windows Phone 8 has is the Windows Phone 8 SDK is an HTML5 app. So let's just grab one of those. And of course, this is now not exactly the same. So in Windows 8 applications, we're able to build the entire app with JavaScript. With Windows Phone applications, we build an application with C# and XAML. But we can build one that just hosts a web browser control, and most of the content is actually being rendered in that web browser control. And that's what this template gives you by default. So what I can do here is just delete the existing HTML assets and do the same thing as before. So let's go and grab these files. And we have these 2 files here again. And there's one change it turns out I have to make to this template, which is that by default, it prevents scripting. By default, it prevents scripting until after I've navigated the page, whereas I'm going to need it to enable scripting before. So we'll make that one change and then run this. And inside our emulator here, we'll see that my application starts up. And when I click Start, inside the phone emulator, I'm running that exact same code again, using web workers, again, everything. This is the same IE10 JavaScript engine running all this code. But I'm doing that inside the phone. And so exact same code again running in this environment as well. I think this is some of the power of having the shared runtime environment across these languages. Now, the last one is actually to do this inside Windows Azure. And so Windows Azure now supports Node.js as one of the things you can target and deploy into Windows Azure. And so what I have here, I have a simple folder. You'll see that I have inside this folder that same raytracer worker.js. And just to prove it's the same, let me copy raytracer web. And I'll just copy it over this, and then, oops. Well, you see that there's no changes here to the raytracer worker. So the copy I have here is exactly the same one I've shown you in these examples. But let me show you the new file I have. So the one other file I here is this server.js. And so this is a simple Node.js web server. So Node.js, for those who aren't familiar, is a server-side JavaScript framework, which allows me, for instance, to create a simple HTTP server here. And so you'll notice that I'm just requiring that raytracer worker, that exact same file I've shown you in these other examples. And then it just create a simple web server around this that just when it gets requests, it hands them off to that raytracer and renders the content, and then returns them back as part of the result. You'll notice that I'm returning them as gzip because what I have is I actually have this posted up on, let me come up here. I actually have this posted up on Windows Azure. So this site that I've got is up on here. And you notice that, oh, nice, it just reset, 23 hours and 49 minutes, great. So it turned out a few minutes ago, this was already using up a lot of my bandwidth here that I'm allowed. And so you can do something simple like add gzip compression in. But the key thing here is I'm actually running that service that you just saw inside Windows Azure here. And so now what I can do is actually open up a Windows 8 application. And this is exactly the same application that you saw a second ago. Oh. Let me open up the right one. Okay. So this is exactly the same piece of code that you saw before when I did the Windows 8 application. So all of this is the same. But the one thing that's different is that I have created this thing called a remote worker. So a remote worker looks and feels like a worker from inside the application, but just uses XML HTTP requests to send those requests over to the server instead. And I create instances of this that point at that Azure website that I had. And so now what I've done is taken that implementation of the ray tracer and just moved it onto the server. But everything else about my application is the same. And if I run this, you'll see I have the same application. And when I run it, I'm actually farming that all off onto the web server. You'll see that this is spreading out even more because the latency to the network is taking a really long time. But I'm actually sending out a separate XML HTTP request for every line, every scan line in this file, and having that compute done on the server. This would be obviously terribly, terribly inefficient to actually do in practice. But it shows you just how easy it is. I can take that exact same code, run it in all these different environments, and get the same application behavior here. So really, really powerful reuse of JavaScript assets that's available because of this. OK, so just to kind of wrap up, the sort of key things I wanted to get across here is that JavaScript now is become a lot more powerful in a few ways. One is the performance is significantly changed. And that means that the things you can think about doing with JavaScript are really different. There's APIs now that make it possible to work with things like binary data and use multiple threads of control from within JavaScript, which also opens up new kinds of opportunities for JavaScript applications. And as it applies to the platforms at Microsoft that you've been learning about in all the sessions throughout this week, JavaScript is available across all of those using the same standards-compliant JavaScript engines, the same high-performance engines that we have for all these different platforms. And so with that, let me just say thanks and open up for any questions. Thank you. So there's some microphones in the middle for folks who have questions.
On? Or this one?
Yeah, I think it's on, yeah.
Okay. Hello, excuse me. Is there any plan to port Win.js to Windows Phone 8?
I cannot speak to that. I have no idea. You come chat with me afterwards. I could try to find a contact for you, but I'm not sure.
Thank you.
Those ECMAScript the new ECMAScript things like the get and set, those don't work at all on, say, IE 6 or 7?
Yeah, that's right. So I should have mentioned that. So the one of the things that obviously happens when the standards body moves forward, that only moves forward kind of at the head browsers. But we certainly see that it takes a while before you can actually use those broadly on the web. And so that's why generally a lot of developers aren't aware of some of these features, because they're not something you can really use on the broad web. Because if you're still if you have users of your sites who are on IE6 or IE7 or even older versions of Firefox and Chrome, you won't be able to use those features because they will break the site. And so there are some tools which sort of polyfill these. So the array APIs, you can get tools which fill those in for you, so you don't need to have the implementation in the browser. But yeah, that's part of why people tend to not be as familiar with these. Part of the point of what I was trying to kind of get across here is that in a lot of our platforms, in Windows 8 and Windows Phone 8, on Node.js, you actually are guaranteed to have a runtime environment where those are available. So when you're targeting those environments, these are things which you can leverage sooner than you might be able to on the broad web. All right. Sounds like that's it. I'll be around for a few more minutes in case anyone has questions, so thanks again.